Welcome to Math Concept Enhancer. Today we will discuss on real number system. We know that there is one-to-one correspondence between a real number and a point on any straight line. So, due to the comfort in general x-axis taken as the representative of real numbers. Now, focus on what is neighborhood. Neighborhood, basically, neighborhood is if A is any real number, A belongs to any real number, then epsilon neighborhood of A neighborhood is a epsilon neighborhood of A contains those real number contains the real numbers whose lies between a minus epsilon to a plus epsilon. If you distinguish, suppose A is a point and the neighborhood of A is defined for epsilon greater than 0 for any epsilon greater than 0 where epsilon is arbitrary number A, A minus epsilon, A plus epsilon. These all points are neighborhood of A. These all points are the neighborhood of A. So, epsilon neighborhood of A is basically x belongs to R, which is mod of x minus A less than epsilon. That real number which lies between A minus epsilon less than x less than A plus epsilon. If A is any real number, then epsilon neighborhood of A contains those real numbers whose lies between A minus epsilon to A plus epsilon. This is the definition of the neighborhood. What is neighborhood? This is definition of epsilon neighborhood. If we consider a example, that is, what is the half neighborhood of minus 2? That is, here we consider epsilon equal to half and A equal to minus 2. Epsilon equal to half and A equal to minus 2. Then n half minus 2 equal to nothing, x belongs to R such that mod of x minus of minus 2 less than half. That is, x belongs to R such that minus half less than x plus 2 less than half. If we put the value, then we find that n f half minus 2 belongs to open interval minus half minus 5 by 2 comma minus 3 by 2. That is our the epsilon neighborhood of half. This is the concept of neighborhood. Second, we will discuss what is the concept of neighborhood of point. For this, first we look what is the deleted neighborhood of epsilon. If we exclude the point, if we exclude the point A from the epsilon neighborhood of A, then we get the deleted neighborhood of A. Then we get the deleted neighborhood of A. So deleted neighborhood is nothing. We simply taken that x not equal to A. X not belongs to A. So 0 less than x minus A less than epsilon. This basically thinks that to omit the point A, we take this 0 less than. So that is our deleted neighborhood. Now focus on the what is the neighborhood of a set. What is a neighborhood of a set? Let a set is which is always subset of R, as we discussed on real number system. So a set S is said to be a neighborhood of a point A. So what is the neighborhood of a point A? A set S is said to be a neighborhood of a point A if there exists a neighborhood of A which contains in the set. Suppose a point that is A. This is the set which is a subset of R. Suppose A is a point of S. A is a point of S. This, if we consider the epsilon neighborhood, that is A minus epsilon and A plus epsilon, and this epsilon neighborhood if subset of S, then we call that S is the neighborhood of A. S is the neighborhood of A. So this is the definition of neighborhood. So there exists epsilon greater than 0 such that n epsilon a subset of S. Now we shall discuss the important thing, that is example. If we consider S equal to R, that is if we find the real number neighborhood, then we get that any A belongs to R. We find that A, for any epsilon greater than 0, we find that A minus epsilon and A plus epsilon, which is a subset of R. That means every neighborhood of every real number is contained in the set of real number. Every neighborhood of every real number is contained in the set of real number. Now, if we consider S equal to Q, that is rational number. A belongs to Q, that is epsilon greater than 0. So, n A epsilon equal A minus epsilon A plus epsilon, which does not subset of Q, as in the neighborhood of, in the domain of A minus epsilon and A plus epsilon, you find that many irrational number and as well as many rational number. So this interval does not belongs to Q, as it contains infinite number of irrational number. So no neighborhood of any rational number is contained in the set of rational numbers. So this is our main concept. So find the neighborhoods of the set open interval 0 1 QC, that is set of all irrational number, and R minus n. So thank you for watching this video.